Hey, what's up, guys? This is Chung here again. So this time, number 31, today's daily challenge problem. Next, permutation. Very classic permutation problem. Okay, so you just need to implement the next permutation, which rearranges the numbers into the lexicographically next greater permutation of numbers. And if such an arrangement is not possible, it must rearrange it as the lowest possible order. And the replacement must be in place and use only constant extra memories, so which means that you can only do a in-memory swap. So for example, we have 1, 2, 3, and the last one is not the last one. The next permutation is 1, 3, and 2. And for 3 to 1, right? And then since there's no next greater permutations, that's why we have to rearrange it to sort it from 1 to 3. Basically, if it's the greatest one, the next one is the smallest one, right? And the next one, this one is 115, and the next greater permutation is 151. Yeah, so that's it. I mean, from these examples, right, actually, it's hard for us to find the correct examples of the what does the next permutation mean, right? Mm. So let's find a more complicated examples. Let's say we have 1, 2, 3, 5, 4, 3, and 2. How about this one? So for example, this is the numbers we're trying to work on, right? Mm, okay, so the the numbers, right? So where's the place we need to do the reverse? I mean, since we know that, if everything is increasing from the last one to the going to the left, then there's no way we can do the swap. So basically, the first number, the number we need to swap is the first one that's that's decreasing, which means it's 3. Because 2, 3, 4, 5, they're all increasing. There's no way we can make this part a greater number. So it's only when we have like a smaller number than the previous one, then we can try to swap this one, right? So that's the number we are trying to do the permutation. But which numbers? Of course, we want this one to be as small as possible, right? And what's the smallest number we can use? Of course, it's the first like the greater number from right to the left, uh, which is 4, right? Because since since we already making sure the others the numbers are sorted from the last one until this point, right? We just need to do another for loop from the end to the until this number, and the first when we find the first number which is greater than the current one, in this case is 4, and then we know this 4 must be the smallest number on the right side, which is greater than the current one. That's why we can because again, right? So on the right part, it's already sorted. That's why we can just swap this one. Now this one becomes to 4. This one becomes to 3, right? Because we can only do the in-memory swap, right? But after this one, is this the smallest one? No, right? Since since this one has already become a bigger value, right? So all the values on the right part, on this part, we have to be we need to reverse. We need to reverse the order for this part because since this one is already bigger, 4 is already bigger than 3. So to be able to in order to get the maximum, sorry, the minimum, right, next greater numbers, we have to make sure the part on the right side on the right side of this current position has to be the smaller value. And again, right, after swap, the right part is still assorted. It's still sorted in the descending order, right? And all we need to do is that we just need to reverse the right part to 2, 3, 3, 5. So now the 1, 2, 4, 2, 3, 3, 5 will be the next permutation. Okay. So and that's going to be our strategy here. So two steps, right? The first one is to find the first index that we need to do the swap. And the second step is to find another the index 2, which is the smallest number who is greater than the index 1. Then we just swap those two numbers, and then we just reverse the right part to get the smallest. So yep, and we can just start our coding, I guess. And so n is length to nums, right? Okay, so and so we have index 1. So the index 1, let's see, we have none because it could be that, we never find the index 1. For example, in this case, right? So in this case, we have to somehow swap everything. I'll just initiate index 1 with none, and then start from the beginning, right? N minus 1 to 0 dot minus 1 because we'll be comparing with the previously one, right? So if the numbers of I is greater than the nums of I minus 1, right? Because this one means that, the current one, I'm sorry, the 5, this is I, right? So when the I is greater than I minus 1, then we know we find the first index. You can do it in different ways. I'm just using this one. You can actually uh, do a I compare with I plus 1, right? It doesn't really matter. Either way works fine. So, but in this case, the index 1 will become to I minus 1 in this case, and then we simply break, right? Cool. So, and then if the index 1 is not empty, it's not null, right? And then we know, okay, we find the index that we want to swap. So the next thing is that we need to find the index 2. And to find the index 2, again, we loop through from the end, right, of this array here. We need to find the first index, first number, who is greater than the current index 1's number. Stop at we stop at the at 1, right? Because we already have a number, right, ahead of us. And if the nums I, right, is greater than the nums of index 1, then we know we find the index 2. So index 2 is equal to I, and then we break. Okay. And then first we swap the index 1 and index 2, right? And then we'll reverse the index 1 plus 1 to the n minus 1, right? Else if we didn't find the index, right? And then we simply need to reverse everything, right? 0 to n minus 1. We can create a helper functions here, do the reverse, right? So we have left and right, and here just like while left equals to smaller than right, nums dot l I mean, this is very like a basic, right? Reverse string reverse a string array in place reverse, right? For sorted array. Okay. Yeah, I think that's it, right? And let's run the code. Oh, +1. Yeah. Right. Submit. Cool. So yeah, I mean, so we have like these two scenarios here. Let me see. Actually, here, maybe we don't need this if else here. You know, the since they're almost the same, right? So if index is index +1, yeah, I'm thinking if we can combine. I think we can, right? I mean the if we initialize index to 0, right, and then so if this 3 to 1 case, right, we always okay, index equals to that. Uh, yeah, we can initial start with, from -1. So if nothing happens, right, and then this one will stay as -1, and then here I just do if this one is doesn't equals to -1, right, and then we know that we can do that because the reason being is I see that we have like this we have this index minor +1 here. I think we can just since we initialize with -1 and then this if this index doesn't exist, we can index -1 +1 will just happen to be 0, so that we can just remove this else here. We can just use this one to do the reverse in the end. Okay, right? Yeah, I think this should also work. Yeah, submit. Yep. Anyway, just a little bit of cleanup for the code, but you guys get the idea, right? The basically we find the first position that we can make it bigger from from the end to the beginning. And once we find that, the next step is that we just need to find the smallest number who is greater than this index one, which will happen to be another for loop from the end, and then we do the swap. After doing the swaps, we also need to make sure the remaining part becomes the smallest. That's why we do a reverse from index 1 plus 1 to the n minus 1. Mm, cool. I think that's it, right? I mean, time complexity, I don't think there's any necessary to calculate time complexity because it's simple two for loops, right? And then there's a reverse, so it's O of n. Cool. I think I would stop here and thank you for watching this video again, guys, and stay tuned. See you guys soon. Bye bye.